Good morning, friends. We start PCC2, ASME PCC2 2018, Article 212, fillet welded patches. This repair method describes the selection criteria, application, limitation, design, fabrication, examination, and testing of fillet welded surface patches to pressure retaining components. Similar fillet welded surface patch repair methods with reinforcing plug welds are provided in Article 207. The pressure retaining components. The repair method consists of fitting a repair plate to closely match the original component exterior or interior surface. The repair plate is sized to cover the areas exhibiting damage both at the time of repair and that are anticipated for the repair's design life. The repair method is typically applied to pressure retaining cells that have suffered local wall thinning, including through wall due to erosion, corrosion, and other local damage mechanisms. The repair method is applicable to cylindrical, spherical, flat, and conical cells as well as the other pressure components. The repair method is generally suitable for service temperatures above nil ductility temperature of the material of construction up to the maximum design temperature of 345 degrees centigrade or 650 degrees Fahrenheit. Use of this repair method for lower temperature requires evaluation of notch surface. Non-ductile fracture and other applicable low temperature effects. Use of these repair methods for higher temperature requires evaluation of thermal fatigue, creep, and other applicable high temperature effects. Figure 21211 shows typical application on a vessel with a nearby structural discontinuity. In this case, a nozzle. The plan view of the top on the top shows two of many possible repair patches configuration, which are generally rectilinear in shape with rounded corners. The bottom section view shows the curvature matching the aspect of each repair plate. So this one, that's what it is telling. The perimeter of the weld 75 mm, 3 inch radius minimum. These things. This repair method shall not be used where the damage mechanism, the extent of damage or likely future damage cannot be characterized. The repair method may be used in certain cases on areas with local crack-like flaws provided the growth has stopped, been arrested, or can be accurately predicted for all propagation modes. The effect of flaw is evaluated using detailed analysis. Design ASME BPVC Section 8 Division 1. However, if the component to be repaired is subjected to bending, torsion, wind loads, or fatigue, the design shall include evaluation of these conditions using appropriate methods of analysis. All the cases, engineering analysis shall be performed. In general, the patch material and welding filler metals should be the same or very similar composition, physical and mechanical properties to that of the pressure component original construction. The thickness of patch plate is dependent on material mechanical properties and the calculated attachment weld sizes. The size, length, and width of the patch plate is governed by requirement that all attachment welds located on sound base metal completely encompassing the damaged area. The patch plate should overlap sound weld metal by at least 25 millimeter or 1 inch. That is which unit you are following. The repair method is generally used on the outside surface of the component subject to internal pressure. For application on external pressure, a separate analysis to evaluate buckling and other instability considerations shall be performed. In assessing the applicability of the service life of the repair method, consideration shall be given to material compatibility, future operating condition, thermal shrinkage effect, welding, introduction of crevices, and structural discontinuities, thermal transient, and temperature differential between the patch plate and the component, and for application limit and other application limits such as examination testing constraints. The damage to the patch is expected to be through wall, the effect of fluid entrapment, concentration, corrosion, etc. If this repair method is to be implemented during the component operation, additional precautions may need to be taken for personnel safety. The design may consider the combined strength of the patch plate, considering also strength of the fillet weld joint, including joint efficiency and the underlying cell. Circumferential load FCP equal to PD by 2 and longitudinal load is PDM by 4. It is PDM by 2. The longitudinal force, and this is circumferential load. So this is always higher, you see. So FC equal to FCP plus FCO and FL equal to FLP, FLO. CO is circumferential force due to other applicable loads. FLO is longitudinal force due to other applicable loads. Appropriate alternative force calculation for spherical to spherical ellipsoidal pressure components. I think these things are necessary. Structural discontinuity, small for designer. Structural discontinuity evaluation for stress near the nozzle or the other structural discontinuity to be insignificant. The minimum distance between the fillet welded patch plate and the existing discontinuity should be L min is 2 RMT root over R RMT. So L min is the plate setback distance. Setback distance is this. This is the plate setback distance. Then RM is the radius at midwall of the component. Mm or inch, and T is the wall thickness of the component in or inch. So this setback is distance RM root over RMT to both the existing nozzles for other similar structural discontinuities and the patch plate. This proximity limit also applies to distance between the adjacent fillet welded patch plates in the application where more than one is employed on a given component. In those applications where the patch plate is to attach the existing nozzle reinforcement pads, the patch plate may be contoured to match the reinforcement pad perimeter and welded thereto with the full penetration joint. In those applications where the damage cell is within L min of a nozzle or other structural discontinuity, the patch plate should be designed as reinforcement pad exceeding 360 degree around the nozzle opening and the welded thereto with the full penetration joint. Alternatively, additional detailed analysis may be performed to evaluate local stresses. Allowable load on perimeter fillet weld. FASW mean ESA. The minimum design fillet weld size shall not exceed the thickness of thinner material being joined nor 40 mm, 1.5 inch. Alternatively, the perimeter weld edge preparation may be built to increase the weld's effective throat thickness. Plate edges may be cut to shape and size by mechanical means such as machining, shearing, grinding, or by thermal means such as flame or arc cutting. If thermal means are used, minimum of 1.5 milli, that is 1 by 16 inch additional material shall be removed by grinding or machining if the repair plate is greater than 25 mm thick and the fillet weld size is less than the plate thickness. The weld preparation edges shall be examined by magnetic particle MT or liquid penetrant PT method to check lamination. Lamination shall be cause of rejection unless repaired or found acceptable by fitness for service analysis in accordance with API 579-1 ASME FFS 1. The patch plate may be formed to the required shape by any process that will not unduly impair the mechanical properties of the patch plate material. Split sections may be used when joined by full penetration welds. Purse fillet welds should be fit as tightly as practical to the surface of the welded and in no event shall be separated by more than 5 milli, 3 by 16 inch. If the separation at the fraying edge of the plate is 1.5 milli, 1 by 16 inch or greater, the size of the perimeter weld shall be recalculated by adding the amount of separation to the eccentricity. Welding procedure, welder and welding operators shall be qualified in accordance with the current requirement of the applicable construction code or post-construction code. It is not otherwise specified. ASME BPVC code section 9 may be used for procedure and performance qualification. Article 210 should be consulted for in-service welding use. Article 214 should be consulted field heat treating issues. Field repair activities should conform to the following sequence. Paint, scale, rust, liquid and other foreign materials shall be removed from the weld zone and area not less than 40 mm, 1.5 inch on either side of the weldment. In those areas that will be covered by the new patch plate, existing shell seam or girth welds should be ground flush with the vessel or pipe body and should be examined by MTPT method. The new patch plate may be placed on position using any suitable method. Any seam within the patch itself should be made first. The perimeter weld may then be completed. Clamps or wedges may be used to ensure proper joint alignment and fit up. Exposed metal surface should be recoated. If applicable, after completion of all examination and testing, to produce gas pressure buildup between the patch plate and pressure component boundary, provisions for venting during the final course of weld, or if applicable, post-weld heat treatment may be necessary. The patch plate is designed for through-wall defects but applied to the pressure boundary before being breached. The vent should be sealed after completion of welding and if applicable, post-weld heat treatment. Examination either MT or PT method. And E shall be performed using procedure written and qualified in accordance with ASME BPVC section 5. If lifting locks are used and left in place, their attachment welds shall be examined by MT and PT method. The removal areas shall be examined by MT-PT methods. Radiographic ultrasonic examination methods to the extent possible. Multilayer PT-MT examinations should be performed. Post-weld heat treatment is required. The examination shall be performed after PWST. Acceptance criteria, construction code or post-construction code shall apply. Testing shall be performed in accordance with the applicable post-construction code. The pressure component and installed patch plates should be leak tested in accordance with the applicable post-construction code. Special safety precautions should be taken. Pneumatic leak testing is performed. If permitted by the applicable post-construction code, non-destructive examination may be performed as an alternative to leak testing. Also, an initial service inspection may be performed of all weld joints after the pressure component has returned to normal operating pressure and temperature. If these were reduced while welding was performed, testing and inspections should be performed prior to reapplication of coating, insulation, or jacketing as applicable. We'll stop here.